So, grades, last week we learned a couple of new things to do when we were simplifying equations. This week, we're going to combine them all together. All the questions we're looking at this week are going to be harder questions. So, for the most part, level 5, 6 questions, a couple level 4 questions. So, this is where like algebra is more and more challenging. There's a lot of things to keep in mind. So, we're going to kind of take it a little bit slow. Mid next week, we're going to have our unit test on algebra. I can't remember off the top of my head. I think like Wednesday, Thursday, end of next week-ish. So we learned about distributive property last week and combining like terms. So a question like this one that's written here, that's a big question. There's a lot going on. Whenever you're faced with a question with lots of steps like this, this is the order that I've written here for you that you go through solving it. So the very first thing says distributive property. So remember, distributive property is when we do our little arrow. So we're going to go 2 times x and 2 times 1. Can someone raise their hand and tell me what 2 times x is? Yep, 2x. What is 2 times 1? Shout it out. 2, good. So that's like the first step. Distributive property is actually written twice in this question. We are all writing this down. Yes, Allison? Sorry, say that again? Yeah, I didn't write it 2. I said 2 though, didn't I? My apologies. Definitely a 2. Okay, this next portion, it says minus 3 times 2x minus 2 in brackets. We have to remember that that minus sign is like attached to the 3. We want to think of that as one thing all together. So in this one, when I multiply it, we're really going negative 3 times 2x, which gives me negative 6x. Does that make sense? Because I had a negative times a positive. The second part is then negative 3 times negative 2. Again, that negative sign is like attached to the number in front of it. Negative times a negative gives me a positive 6 equals 4. Let's say you came to a question that was big like this, but it didn't have distributive property. Do you think you have to do distributive property then? No, you just move on to the next one. So this is always going to be for these big, scary questions, or really any question in general. If distributive property is there, you probably need to do it first. Is this a hard and fast rule, as in this applies to every situation you will ever come across? No. You have to think a little bit. So remember, at the end of the day, BEDMAS, or order of operations, is always at play. With algebra, we're actually kind of doing it backwards, but we still have to keep it in general going forwards applying too. So that's why we do distributive property, because it's brackets. We have to do that first. So step 2 then says combine like terms. So things that are similar, you can combine them. Something that might be helpful for some of you that are struggling with this concept, x's are similar. So I'm going to put a box around all of my x terms. My solo ones are also similar. So maybe I'll put a triangle around those, because those things are like each other. They're the same type of thing. If I have 2 x's and I take away 6 of those x's, how many x's do I really have? Let's have hands for that one. So I have 2 x's and there's minus 6 x's, because you always keep the sign that's in front of the letter with it. Anders. Good. Then 2 plus 6. Shout it out. Thank you. What sign goes right here? Good, because it was a positive 8. So now this question's actually pretty simple, right? We would describe at this point as a 2-step question. It takes 2 steps to solve this at this point. So I now have minus 4x plus 8 equals 4. Well, the next direction here, it says cancel out the constant or the floater. What is my floater here? 8. Good. Can someone raise their hand? How do I cancel it out? Noah. Good. It cancels out because really this is equal to 0. So now I'm left with minus 4x equals minus 4. What is my next step? Good, I want to divide, and I'm going to divide by a minus 4. I'm doing a minus 4 so that way my negatives cancel out and my 4's cancel out. So then I'm left with x equals 1. Okay, great. So I want you to take a second, look at your notation. Are all of your equal signs relatively in a straight vertical line? Relatively. Like even mine are not perfect. If I drew a relative straight line, I'm going to just about hit every single one of them. Technically, I missed one. That's okay. It's pretty dang close. That's okay. The next part, it says check. What does that mean? What does it mean to check? Am I just going to look back and be like, looks good? Go ahead, Amy. Good. Do you know what the math word for that is? We're going to substitute. So we're going to substitute in our answer. So the original equation, I'm going to write it down again just so it's all in one spot. You don't have to do this step here. But the original question was 2x plus 1 minus 3 times 2x minus 2 equals 4. So when I substitute, instead of writing x, I'm going to write a 1. So then it's going to be 2 times 1 minus 2 equals 4. You can do this next step in a lot of different ways on questions like this. Totally kind of personal preference. I'm going to go 1 plus 1 is 2. So I'm going to rewrite that as a 2. 2 times 1 is 2. Rewrite minus 2. So I'm just going to highlight so you guys can see the things that I did on each line. Those are the changes. Am I showing a lot of work here? Yes. If you can show less work, that's just fine. On something like this, you might be able to do more in your head than someone else, just fine. Okay? 2 times 2 is 4. 2 minus 2 is 0. 3 times 0 is what? 0. There should not be a question mark. You all should know that. Does 4 equal 4? Good. If we made a mistake, it would end up saying 3 equals 4. Is that a true statement? No. And that's how you know you made a mistake or not. Do you have to always do a check? No. Could you always do a check? Yes. I will make you do a check at least once on your unit test. How was that? Great, good. Okay, try this next one on your own. Showing all of your steps, showing all of your work. Solve for K. You're going to do the same steps as the previous one. And I'm just going to see if my internet's working, so if I could hook up Zoom or not, or whatever's happening. Sorry. So with questions like this, one thing to keep in mind, this unit specifically, generally speaking, is not a time for creativity. Sometimes in math, you can be very creative. In algebra, there's 0 creativity allowed. Why am I saying this? And you always have to follow the same steps. You always have to do it in order to do it correctly. If you don't follow those same steps, you could still be doing it correctly, but you might be adding a ton of extra work. So for example, if I times both sides of this equation by 10, is that allowed? Yeah, because I did the same thing to both sides. Was it helpful? No, not at all. Is it correct? Sure. But was that a helpful thing to do creatively? No, so don't do it. So first step is distributive property. So I'm going to rewrite my 8. Is it okay that my 8 like my solution is on the left side this time? Yes, totally fine. Depends how I present the question. 3 times 2k gives me 6k. 3 times -4 is -12. Make sure you wrote -12. Then I'm just going to rewrite the rest. Everyone should have this line written on their paper. Identical to me. Cool. What's my next step? Let's have hands. What's my next step? Keaton. Good. So, D for distributive property. Combine like terms is C, so I have 8 equals, I have 6 Ks and 2 more Ks. How many Ks in total are there? 8. So remember, it's saying like, if we go back to algebra tiles, I have a group of 6 tiles and then I have a group of 2 tiles. In total, there's 8. Literally speaking, are there only 2 Ks written down? Yeah, but it's that 8 in front is showing that there's multiples of them. So 6 plus 2 gives me 8 Ks. -12 minus 4 gives me -16. Everyone should have that same line written down. So that's combined like terms. So now I'm going to do addition or subtraction. So what am I going to add and subtract? Or subtract, I should say. Jasmine? Add 16. Good. So plus 16 to both sides. What's 8 plus 16? Good. Last step is do my multiplication piece. So I'm going to divide both sides by 8. K is equal to 3. Raise your hand if you got K equals 3. Just same thing. Good work, guys. This is a hard question. These are really hard. Raise your hand if your equal signs are in a vertical line. Raise your hand if you did 4 steps or 4 lines in solving this or more. If you did 4 or more, that's fine. If you did less than 4, we likely have a situation. You could, I said likely. Okay, cool. Those are pretty tricky questions. There's a lot going on, a lot to remember. The next part of our unit where this gets to be even trickier is there's going to be variables on both sides of our equation. This is the last thing. This is it. Okay. What are we looking at here? What's this a picture of? Not boats. Definitely not boats. A scale. Allison, you need to spend more time on water. A boat looks like that's a boat. So on this scale, that's not a boat, it's a scale, it's showing that the 2 sides are equal, like a teeter-totter. They're equal to each other, so they're level. On the left side of the scale, I literally have 2 x's and a -1. That's got to be equal to the right side where I have a singular x and 5 ones. Do you all understand where I came up with this equation? Cool. Cool. So is there distributive property to do here? No. When I look at this, I have things on both sides, but can I combine anything on a single side? Like on the left side, is there anything to like clean up? No. On the right side, is there anything to clean up? No. So you're actually going to see to our like little steps that were on this first page. Right here is where we deal with variables on the both sides. So there's actually a bonus step that we're adding in. We just determined we can't do, there's nothing to do for the first 2. So the next one is going to be to move our terms over so there's only stuff on each side. So I want to cancel out an x on one side, so I'm going to subtract an x from both sides. If I go minus x, on my right side, are there any x's left? No, they cancel out. What is 2x minus x? What? I don't know why I wrote that x so high up. Go ahead, Anders. Really good question. Good, really good question. So why, I'm just going to say it again. Why did I choose to subtract 1x from both sides? I could have chosen to subtract 2x's from both sides. Totally. The reason why I chose to subtract 1x is because then I was left with a positive. Life is easier if it's in positives. You totally can choose whatever side your heart desires. Your steps and numbers are going to look a little bit different in your process, but your answer will be the same.
And did it have to be x?
You could, you're just gonna have to do the x's later. So like right now, you're gonna see now I'm gonna cancel out the 1, right? So it doesn't matter. You can do your 1s, then your variables, or your variables, then your 1s. I think it's easier, Anders, to do your variables first. Okay, so from here, I'm gonna cancel out this plus, this minus 1 by adding 1 to both sides. So then I get that x equals 6. What's going to happen to you in this unit is there's going to be distributive property. You're going to combine like terms. You're going to have variables on both sides. All of these things are going to come into one question. And that's what we're going to work on for the next day and a half. Okay. Once you've got this written down, turn the page. So in this first one, very similar question to the last one. Just my 1s are different, right? I have 2 x's on the left and a single x on the right. Let's do what Anders said. Let's cancel out the 2 x's. So if I chose to subtract 2 x's right away, that's totally fine. I did the same thing to both sides. Overarching rule. Same thing to both sides. When I do that, these two cancel out, they're equal to 0. Cool. This 14 is left. Is that 14 a positive or negative 14? Negative. Don't forget to rewrite that minus sign. That's a super easy mistake that you're likely to make. This x initially, I could have written a sneaky number 1 there. Do you guys agree? Right? I have 1x, or I could say I have x. I have a coffee in my hand. I have 1 coffee in my hand. Same thing. What is 1 minus 2? Good. So now I have negative 1x minus 9. Who can raise their hand? What is my next step in solving this? Just me. I add 9 to both sides. So now I'm going to write plus 9, plus 9. Those are equal to 0, so they cancel out. So I'm left with a negative 1x. What is negative 14? Let's have hands here. Negative 14 plus 9. Noah. Negative 5. Good. Okay, remember, we want to solve for a positive x, not negative x. No one cares what negative x is equal to. Not helpful. It's not relevant. How do I get rid of that negative 1? Jasmine. Right on. So I'm going to divide by a negative 1, divide by a negative 1. My negatives cancel. Do my 1s cancel? Kind of not really. There still is a 1 because 1 divided by 1 is 1. X equals 5. By subtracting 2x initially, we had that extra step at the end to make it a positive x. Was it that difficult of a step? No. But it's an extra step. Okay? How was that for everyone? Any questions? Are we feeling good about this? We're feeling okay? Try this next one on your own. Beside. 12 minus x. Try that one. What is my first step on this one? Or what is a possible first step? Ananya. Cool. Add x to both sides. So plus x plus x. These two guys cancel out because that's equal to 0. So I'm left with the 12 on my left side. Negative 2 plus x gives me a negative 1x. Could I have written that as just negative x like that? Totally. Same thing. What is my next step? Hands. Just me. Good. These cancel out because they're equal to 0. 12 minus 18. Negative 6. One way that might help you if you're struggling with integers is flip your numbers. What's 18 minus 12? 6. The original question was 12 minus 18. 18 is the bigger number. So in the end, my answer had to be negative. So then it's going to be a negative 6. At the end of the day, it's still the difference between those two numbers. You just have to decide if it's positive or negative. So negative 6 equals negative x. Are we done? No. We want it to be a positive x, so I'm going to divide both sides by a negative. X equals 6. What? Yep. Yeah. Did you get the same answer as me? Yes. Totally fine. So the question was, if we did the first step, so if you added 2x instead, all of this is going to be slightly different. Slightly different. But this will be the same. So do you think it's fine? Yes. Okay. This next one, I'm going to do this one really quick with you. First step is what? Good, distributive property. So I'm going to multiply the 2 in on both of these. 2 times x is 2x. 2 times 1 is minus 2 equals 3x. There are x's on both sides. That's not cool. What do I do? Okay, really good question. Really good question. Okay, so Hassan just said, what I'm going to divide both sides by 3. So, grade 8s, don't write this down, but I want you to follow along with this. So, what Hassan just said is not wrong, but it's really difficult. You have to divide everything by 3. So what this then changes to, don't write this down, those 2 would cancel, so I still have an x over here. But this is now 2/3 x minus 2/3. Was that helpful? No. Did that make this question a lot scarier? Yes. Is it wrong, though? No. So doing this, I would argue, it's just not helpful. Is it wrong? No. Just life is a lot more difficult, and I still have x's on both sides. So it didn't actually get me anywhere. It's not wrong. It's just making life a lot more complicated. Go ahead.
Would it be acceptable if your answer was -4 by 6?
Well, let's go through and see. So this should have, sorry, hold on. You totally can have fractions as a final answer. Would what is a more helpful strategy here is let's subtract 2x from both sides. Those cancel out. This is -2. Don't forget the negative. 3 minus 2 is 1, and then I'm done. So dividing both sides by 3 would have just given us like a ton more steps. Not wrong, just a lot more work. Final answer here is just -2. Does that make sense? Yeah. When I subtracted 2x from both sides, we want it to equal to 0 here because we want to get rid of it completely. So we have to subtract, because if we divide, it's going to be equal to 1. And we don't want that. Okay, this next question, I have a fraction. I want you guys to not be scared of fractions. How many of you are uncomfortable with fractions and just don't love them? Love the honesty. Thank you. I would bet if I asked that question to any grade 10, 11, 12 student, they'd all be like, I also don't love them. We're trying to stop that. Fractions should not be scary. So is there distributive property in this question? No. Do I have any terms to combine on each side separately? No. So we have to move our variables to start off, just following along. I just want to remind you of something. 1/2 x is the same thing as x divided by 2. Just remember that. I'm going to start, 1 second, Anders. I'm going to start, if this was just, instead of saying it said 1/2 an x, it just said x, we would subtract an x from both sides, correct? Yes. Yes. But it doesn't. It says 1/2. Let's subtract 1/2 an x. Okay, grade 8s. This is where we don't get scared and we don't get intimidated. What is 3 minus 0.5? Okay, grade 8s, you all should be able to do this. What is 3 minus 0.5? 2.5. Are you sure? Yes. This just says 3 minus 1/2. Is 1/2 the same thing as 0.5? Yes. So I could say 2.5x. Do you guys agree? Maybe? Yeah? Are we sure? Is 2.5 a fraction? It's equal to a fraction. It's just a decimal. Is 2.5 not as scary, though, as writing like 5/2? I think so. My next step in solving this would be to add 1 to both sides. 1's cancel, so then I have 2.5x equals 5. What's my next step? Good. Divide both sides by 2.5. Allison, ask your question. I didn't. I subtracted 3 minus 0.5. My apologies. Grades, how many 2.5s go into 5? 2. So what's 5 divided by 2.5? 2. Except I wrote an x. Who's your teacher here? What's happening? 1x, I should have said. So my answer is 2. That's a terrible 2. 2 equals x. Because I felt like putting 1 there. Do I need a 1 there? No. Could I have just written 2 equals x? Yes. Go ahead.
So with that very top of the question,
Mm-hmm.
where it says, x, you just write 0.5x.
Totally. Totally. Really good point. Do you guys all hear that? Anders just asked, instead of writing 1/2 x, could I have written 0.5? Yes. What if, though, you don't have to write this down, but what if it was actually like 1/3 x? Is that the same thing as 0.3x? Good. So no, it's not. So in that case, no, you can't just change it. In that case, you would have to deal it with fractions. I will not give you that case in this unit because we have not reviewed fractions yet this year. That's our next unit. After our next unit, fractions will come up everywhere. But I'm going to be nice to you in this unit and always give you like 0.5s if I give it to you. If I do at that. Is that everything? Cool. Yes, you had a question. Okay, grade 8s. So, a few of you got some emails from me this weekend being like, you didn't do this, you didn't do this. And then some of you emailed me back and was like, I'm pretty sure I handed it in. I'm pretty sure I don't have it. So if you could, I will double check my office this morning because of my internet situation. I didn't have a time to thoroughly check my office. But if you could also thoroughly check like your lockers and stuff, mostly talking about the murder mystery activity. If you didn't get an email, you're all set. Don't worry about this. But make sure you try and look for me. Today, for the rest of class, you have so much time. We are working on these links. It's 3 links. I'll put this on the board. Some of you already started them. It's W.15. What happened? W15. You have to reach 60. It's in OneNote. W13. And I think it's W16. Let me double check this one. Yes. And W16. I'll put this on the whiteboard. The amounts you have to reach are different. I also strongly recommend you take out a piece of like scrap paper and try and show some steps and things like that on your paper because this is really easy to make mistakes on. You could use the back side of this booklet I just gave you for that matter too to help show some work. So I'll write this on the board. You have to reach 60, 70, and 60 on these. They do get a little complicated. That's why you have so much time to work on them. Okay, so we're working for the rest of class. You should know it.